Okay, today we're going to be talking about the fundamental theorem of algebra. So recall from the fall that we know if we have the zeros of the function that we can kind of work backwards and write the polynomial form of the function. So we're going to use the zeros below to write the polynomial in its simplest form. Okay, so remember when we have the zeros, we know that in the factors, they would be the opposite sign. So this would make my factors x plus 3 x plus 1. And remember when it's 0, it's kind of like we could say it's that x plus 0, but we don't really even need the 0. We can just leave it as x. So I'm going to FOIL whenever I need to simplify. When I have factors, I need to FOIL them back together. So remember first, outer, inner, last. So I have x squared plus x times 1 is x. Inner will give me my 3x, and 3 times 1 is 3. Okay, so then that's when I foiled that. I'm going to simplify a little bit more, but then I also have that x. So I have x times, I'm going to go x squared, combine my like terms. Oops, sorry, that's 4x plus 3. And then I distribute. So then I have f of x is equal to x times x squared is x to the third. X times 4x is plus 4x squared. And x times 3 is plus 3x. So that would be the polynomial in simplest form with those factors. So again, if we were like working backwards, we would, factor out an x and then factor the trinomial, and we'd end up with those zeros up there. Okay, looking at the next one. So we would again change our signs when we put them in. X minus 1/3, x plus 3, and x minus 6. Okay, now remember, this is that, the way we would write it if we were solving it. But if we need to write it in polynomial form, remember, we would want to swing that 3 up to be the coefficient. So that then I'd have 3x minus 1. Okay, now I'm going to go ahead and FOIL these two together. So x, first, outer, inner, last. X times x is x squared. X times negative 6 is negative 6x. 3 times x is positive 3x. And 3 times negative 6 is negative 18. So I'm going to simplify that before I distribute my 3x minus 1. So I have x squared. I combine my like terms. I get negative 3x and then minus 18. Now I'm going to distribute both of these terms into every term here. So I got to take my 3x into everything, and I got to take my negative 1 into everything. So 3x times x squared is 3x to the third. 3x times negative 3x is negative 9x squared. 3x times negative 18 is negative 54x. Negative 1 times x squared is negative x squared. Negative 1 times negative 3x is positive 3x. And negative 1 times negative 18 is positive 18. So now we're going to combine like terms to get the polynomial. So I have no other x cubed terms. So I have 3x cubed. There's that one. I have negative 9x squared and negative x squared. So that's my negative 10x squared. Done with those. Negative 54x and positive 3x would give me negative 51x. And then I have my plus 18. And so that's the polynomial in simplest form. Okay, today we're going to talk a little bit about kind of how we know how many solutions. Now, we've been talking about this kind of for a while, but this fundamental theorem of algebra and its corollary really does tell us, how many solutions. So every polynomial function with degree n greater than or equal to 1 has at least one zero, where the zero could be a complex number. Okay, so again, we've been talking about that. And then the corollary is that every polynomial function degree n greater than 1 has exactly n zeros, including multiplicities. Now, my class, we've been talking about that because every time with synthetic division and all that stuff, I would say, okay, look at the coefficient or look at that exponent. That's how many solutions you should expect to have. So we've been kind of thinking about this and using this, but this is kind of putting it in, stamping it and saying it's always going to be true. So, and we looked at that last unit, last class where we had, we could see that we could use the rational root theorem and find all those zeros. Okay, now this is kind of something new, the complex conjugate rule. So root theorem. So it says if x plus bi is a root of the polynomial equation with real number coefficients, then a minus bi is also a root. This is also true for radicals. For example, if root 6 is a factor, then negative root 6 is a factor. Okay, now if you think about this, like plugging those in, like x minus and then having this, it's really a mess. So there is a trick that when you have these imaginary roots, you can always take it, it's where it's x squared minus the sum of the two roots plus the product of them. All right, so we're going to look at that together. So if we see right here that 1 minus I is a root, then we know that 1 plus I is a root. Okay, so again, what I was kind of saying a second ago is like if we were trying to FOIL this like back together and without using this trick, then we'd have to kind of do like 1 minus I, and x, minus 1 plus I, and then FOIL that, and it would be a mess. So we don't want to do that. We're going to use the sum and product trick. So we're going to say, okay, what's the sum of these two complex numbers? So I'm going to take 1 minus I plus 1 plus I. We see our i's cancel out, and I get 2. And then we're going to take the product. So we're going to FOIL them. So 1 minus I times 1 plus I. So when we FOIL it, we get 1 times 1 is 1. Outer is plus I. Inner is minus I. And then negative I times positive I is negative I squared. Well, we see the I minus I, that cancels that out. And then remember, when I have an I squared, remember, I cross it out, change the sign in front of it, and the coefficient here would be 1. So it makes it a plus 1. So 1 plus 1 is 2. So that means if I did this nasty foiling thing right here, I would end up with the polynomial x squared, and again, it's minus the sum, so minus 2x, and then plus the product. Okay, so there's what the polynomial, if I multiplied those together, and then I have this other 0 right there, so I'm going to change that sign when I put it in. So x is going to be minus 2. And so now I just have to multiply these together. So remember, I'm going to distribute over here. All my terms have to get multiplied over here. So I have x squared times x. That's going to give me x to the third. X squared times negative 2. Negative 2x squared. Negative 2x times times positive x is negative 2x squared. Negative 2x times negative 2 is positive 4x. 2 times x is plus 2x. 2 times negative 2 is negative 4. Now, let's just combine our like terms. So f of x, we start with our x to the third. Then we have negative 2x squared and negative 2x squared. So that gives me negative 4x squared. And then I have 4x plus 2x, which gives me 6x. And then I'm done with those. And then I have minus 4. All right, now our next one. So again, when I see that radical, then I know that I have the conjugate of it, 1 minus root 5. So again, I'm going to do the sum product trick. So the sum of those two, that's going to be 1 plus root 5 plus 1 minus root 5. Well, the root 5's just go away, and I get 2. And then the product, I'm going to FOIL them together. So 1 plus root 5 times 1 minus root 5. 1 times 1 is 1. My outer would be negative root 5. My inner would be positive root 5. And my last, so first of all, it's going to be positive, right? Because it's going to be negative because a positive times a negative will make it negative. And root 5 times root 5, remember, if I multiply a root by itself, it just brings out the number. So my root 5s are going to go away, and I have 1 minus 5, which is negative 4. So then that makes that polynomial, if I use my sum product trick, I have x squared minus the sum, minus 2x, and then minus 4. It's plus the product, but if the product is negative, you just keep the sign. Okay, then I have this other 0 here, so I'm going to put that, x minus 3, and then I just multiply these together. So then that every term over here has to distribute to both of the terms. So x squared times x. I get x to the third. X squared times negative 3. Negative 3x squared. Now I've done that x squared times both terms, so now I'm going to take my negative 2x. Negative 2x times x is negative 2x squared. Negative 2x times negative 3 is plus 6x. Negative 4 times x is negative 4x. Negative 4 times negative 3 is positive 12. Combine all of our terms. So x to the third, got that one. I've got my 2x squared, so that's going to give me negative 5x squared. I've got my 6x, and minus 4x is plus 2x. And then bring down my constant, plus 12. All right, so now I have two different radicals. So I'm going to have the conjugate of both of them, 1 plus root 3, and then I'm also going to have a negative root 6. So I'm going to do the root 6's first because that's kind of the easier one. So the sum, root 6 minus root 6, is just 0. And the product, root 6, 6 times negative root 6. We know it's going to be negative. Root 6 times root 6 just gives me my 6. Okay, in a second I'll come down and write that polynomial, but I also need to do my sum and product over here. So I have the sum will be 1 minus root 3 plus 1 plus root 3. Well, my root 3's go away and I get 2. And then the product, I'm going to take 1 minus root 3 times 1 plus root 3. So 1 times 1 is 1. And my outer would be plus root 3. My inner would be minus root 3. Negative times a positive is negative. A root 3 times a root 3 just gives me the 3. The roots go away, and I get negative 2. Okay, so my polynomial here, I'm going to take that one as my first one. So I have x squared minus the sum. Well, it's 0, so that means I don't have an x term. And then I just have minus 6. And now I'm going to write this polynomial. So I have x squared minus the sum, so minus 2x, and then whatever my product is, minus 2. So now I'm going to multiply these together. So x squared times x squared is x to the fourth. X squared times negative 2x is negative 2x to the third. X squared times negative 2 is negative 2x squared. Negative 6 times x squared is negative 6x squared. Negative 6 times negative 2x is positive 12x. And negative 6 times negative 2 is positive 12. And we just combine all of our like terms. So I have x to the fourth. I have 1x third to the third, so I'm just going to write that one. Now I have these 2x squareds, so that's going to give me negative 8x squared. And then I have just one x term and my constant. So there is our polynomial with those radical factors. Okay, and then same over here. Now I have two imaginaries, so I have to give the conjugate of both. So 3 minus I and 2 plus 3i. So I have to do the sum product trick for both of them. So I'm going to do sum of my first two. So 3 plus I plus 3 minus I. My i's go away and I get 6. I'm going to do product. I'm just shortening it to pro. Okay, so I'm going to FOIL these together. 3 plus I times 3 minus I. 3 times 3 is 9. My outer is negative 3i. Inner is positive 3i. And I times negative I is negative I squared. So those go away. And then remember, when I have an I squared, I cross it out, change the sign. The coefficient there is 1. So 9 plus 1 is 10. So that's going to be the sum and product for that first pair. We'll do the same thing for our other pair. So we've got the sum. I have 2 minus 3i plus 2 plus 3i. The i's go away and I get 4. So that product, FOIL them together. 2 minus 3i times 2 plus 3i. 2 times 2 is 4. 2 times outer, so that would be 6i. Inner would be, negative 6i. and my last would be negative 9i squared. My 6i's go away, cross out that I square and change the sign, so then that is 13. Okay, so now I have one polynomial with those, so x squared minus my sum times x, and then plus my product, and then I've got the same thing here, so x squared minus my sum times x plus my product. Okay, now I have a trinomial times a trinomial, which just means I have to multiply this times every term over here. All three terms just have to distribute into the second one. So it's going to have a lot of terms. So x squared times x squared, x to the fourth, x squared times negative 4x, negative 4x to the third, and x squared times 13 is 13x squared. Okay, I distributed the x squared, so now I'm going to move on to my negative 6. Negative 6x times x squared is negative 6x to the third. Negative 6x times negative 4x is positive 24x squared. And negative 6x times positive 13 is, let's see, what is that? Negative, I think I messed up on my practice earlier. Oh, wait, yeah, that's right. Okay, that is 78. Sorry, negative 78x, and then negative, I did the negative 6 times everything, so now I'm going to do my 10. So plus 10x squared, that's minus 40x, and that's plus 130. Okay, I have all those terms, so I'm going to just take my like terms and combine them. So I start with my x to the fourth, then I have to combine my x cubed, so I have negative 4 and negative 6, so that's negative 10x cubed. Then I have my x squared, so I have 13 plus 24, that's, what is that, 37 plus 10 is 47x squared. So cross out my x squareds. And then I have negative 78 minus 40, which gives me negative 118x, and then plus my 130. And that would be the polynomial function. Okay, so putting it all together, kind of what we've been doing the last few days. So we're kind of going, the fundamental theorem of algebra says, okay, if we know what that exponent is, that's how many roots we should expect to have. So we're going to use the, what we know about the fundamental theorem of algebra and what we know about the rational root theorem to find all of our solutions. Okay, so going back to kind of what we did yesterday. So remember our P, so that's the 8. So remember that's the factors of 8. So plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Our Q is 1, so plus or minus 1. So our P over Q, you can just arrow down. It's all those factors of P. Excuse me. So now we're going to plug those in, see which one works. So like I said, I usually start with 1. So I'm going to put my 1 in the box. Now I check x to the fourth, x to the third, squared, x, and a constant. So I don't need any placeholders. So I have 1, 1, 2, 4, and negative 8. Give myself a row. Okay, bring them down. So 1, and then I have 1 times 1 is 1. That's 2. 1 times 2 is 2. 2 plus 2 is 4. 1 times 4 is 4. 4 plus 4 is 8. 1 times 8 is 8. And that's 0. So awesome. I'm going to come down here and just say x is equal to 1. That's our first root. Okay, so now remember, we're going to take these as our coefficients now. We don't need that 0. So let's try a next number. So I don't know, let's try negative 1. Negative 1. So I bring down my first one. Negative 1, that's negative 1. That combines to 1. 1 times negative 1 is negative 1. That's 3. I can see this one's not going to work, so I'm going to just move on. Okay, so let's try 2. So I'm going to go back to these coefficients. So 1, 2, 4, and 8. Let's try positive 2. So bring down our 1. 2 times 1 is 2. That's 4. 2 times 4 is 8. That's not going to work. All right, let's try negative 2. So I have 1, 2, 4, and 8. 1, bring it down. Negative 2 times 1 is negative 2. That's 0. That's going to be 0. That's 4. Negative 2 times 4 is negative 8, so that one works. So my next 0 is negative 2. Okay, so now remember, we started with an x to the 4th. We have found 2 roots, so now we are at an x squared equation. So what do I have left? I have x squared plus 4 is equal to 0. Okay, now we can see this is not a difference of squares. It's got a plus, so we're going to have to solve it using square roots. So remember, I'm going to take that x squared, so I'm moving over here so I have a little bit more room, and I'm going to subtract my 4. So I have x squared is equal to negative 4. And remember, I can take the square root of both sides, and I get x is equal to, and remember, if you use a square root to solve, you have to have the plus or minus. The square root of 4 is 2. The square root of the negative is I. So then I have plus or minus 2i. And so that just shows us that if we had the positive imaginary number, we have to have the negative imaginary number. So those are my 1, 2, 3, 4 roots, which is exactly how many I expected to have because my x to the 4th. All right, our last example. So now we've got 20, so we have a few more factors to think about. So we have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5. Let's see, 10 and 20. And then we have Q. That's just going to be plus or minus 1. Okay, so then our P over Q, I'm not going to make you rewrite it. It's just this whole list will move down here. Okay, so then we start, like I usually do, I'm going to start with 1. Okay, so I look and I make sure I don't have any holes. X to the 4th, x to the 3rd, x squared, x, and constant. So I just put those as my coefficients. So 1, 4, negative 1, 16, and negative 20. Bring down my 1. 1 times 1 is 1. 4 plus 1 is 5. 1 times 5 is 5. Negative 1 times 5, is 4. 1 times 4 is 4. That is 20. And 1 times 20 is 20. Yay, found my first one. So again, I'm just going to kind of come down here to the bottom and say x is equal to 1. I found a 0. Okay, so I can keep going. Another thing I kind of want to just point out here is that, if we went to an x to the 4th, then this is an x to the 3rd. Like some of these, you could simplify, see if you could simplify by grouping, right? And again, if you are not a factoring fan, then just keep going with synthetic division. But I just want to point out to you guys that this would be that x to the 3rd plus 5x squared plus 4x plus 20 is equal to 0. And this one actually does group to simplify. Okay, so I can group the first two, group the second two. I bring out an x squared. I have an x plus 5. I can bring out a 4, and I have an x plus 5 is equal to 0. I see those parentheses match, so now I'm going to slide that to the front as my GCF. And then I take the coefficients and put those together. So I have x squared plus 4 is equal to 0. So now one of my zeros I can see is x is equal to negative 5. So I'm going to come put that in my list. But then I have that one that isn't going to factor. So in this one, so again, if you have something that isn't going to factor, then you can try quadratic formula. Or like I said, this one doesn't have that b term. So we could just solve it by square roots to say x squared plus 4 is equal to 0. We subtract that 4. X squared is equal to negative 4. Square root, x is again equal to plus or minus 2i. Okay, oops, sorry, I forgot the plus or minus. Okay, now, but again, if factoring isn't your jam, then you just keep going with synthetic division. But some people get really frustrated when they're like trying synthetic division over and over and it's not working, right? And you're not getting them. And so I just wanted to point out, like, you have a lot of tools in your tool bag at this point to be able to solve these things. So you can look for, some of them will factor like that, some of them won't. And so just look, just wanted to kind of point out that you can also do that and look for that. Not all of those x to the thirds will be able to factor by grouping, but I just wanted to make that point that now you can kind of keep going with synthetic division. You can factor, just usually what I recommend is when you get to that x squared, instead of keeping, continuing to try to do synthetic division, just take those and factor them. All right, thanks so much for watching.